Okay. Pythagorean theorem. So if for any right triangle, you don't have to write this down. The area of the square whose side is the hypotenuse is equal to the sum of the areas of the square whose sides are the two legs. This is how it actually reads. So the Pythagorean theorem, we write it in shorthand, but this is the actual theorem written out in words, and it's literally, here's our shorthand. This you'll want. A squared plus b squared equals c squared. C is the hypotenuse, A and B are the legs. And what it's literally doing, the theorem is literally saying if I take a right triangle and I make a square, the length of the hypotenuse, and I make a square on each side, this square plus this square is equal in area to this square. That's the actual theorem. That's when Pythagoras arguably came up with it. Actually, the Chinese came up with it a good couple hundred years before he did, but whatever, he didn't know about them. But this is what they came up with. They realized that if you take this length and make it a square, and then you count up all these little squares, these squares fit inside this. They're the same size. That's literally how the theorem came to be. It's not algebra, even though we use algebra as a shortcut. It's actual geometry, actual shapes. Yeah, so, no. You take the triangle and you draw a square off of it. All of these squares fit. So if I take like this and account for all of them, so that's all of those, and then all of these, so there's 16 of these. I already did one of them, so I'll just do that, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Same number of squares. Yeah, so that's what they really came up with. If you showed Pythagoras this right here, he would not have any clue what that meant at all. There's just, they didn't have algebra yet. They didn't have symbolization this way. They, like, to prove it, they drew all the squares and stuff. So, but this is the math that we can do today. Even our like in elementary school, the math that we can do in elementary school. If you went back into ancient times and showed that to them, they would think you were just like, no, like that you would be the most amazing genius that ever was. Because they didn't have that type of, they didn't divide, like, they didn't say 5 into 10 is 2, like they didn't know how to do that. They didn't have the symbolization, so it would be, mind-blowing to them. Things that we just go, okay, yeah, that's normal. So a Pythagorean triple occurs when you get a right triangle with perfect integer sides. So, we get a 3, 4, 5 right triangle. That's the one that's just in that picture, 3 and 4 and 5. This would be a Pythagorean triple. Now, any multiple of a Pythagorean triple is also a Pythagorean triple. So I could multiply all of these by 2. This is still a Pythagorean triple. And if I multiplied them by 3, Pythagorean triple. If I multiply them by 4, etc. So once you find one Pythagorean triple, all of the multiples of that are also Pythagorean triples. This is probably the most commonly known one. There's also a 12, 13, something, hold on. No. Something 12, 13. I just don't remember which one it is. 5, 12, 13. That's the other really common one. And then all the multiples of this, of course. Pythagorean triples. No, you do not have to memorize all the Pythagorean triples. But if you do memorize some of them, when you look at a triangle, and if I show you this triangle here, and I have a 3 and a 5, and you know 3, 4, 5, you don't even have to do any math. You can say, oh, that's a 3, 4, 5 right triangle, and then you can just put it in there. So I showed this. We have triangle. The right angle will always point to C. Then the other two are A and B, and it doesn't matter which is which. I could call this A, I could call that B. We don't care. 5 squared and 12 squared. Here, let me write this. A squared plus B squared equals C squared. 25 plus 144 equals C squared. 169 is equal to C squared, and then you need to take the square of each side, and the square root of 169 is 13. It was, yeah. But if you didn't memorize it, this is how you do it. Okay, so, well, let's see what happens if I get one leg and one C. Well, this one's actually, okay, this is a square. Square. So that means this is X, this is X, this is X. Well, this is A and B and C. So x squared plus x squared is equal to c squared, which is 8. 2x squared is equal to 64. Divide both sides by 2. X squared is equal to 32. I'm going to take the square root of each of these, and 32 is not a perfect square. So 32 is 2 times 16. 16 is 2 times 8. 8 is 2 times 4. 4 is 2 times 2. I have 1, 2 pairs, and a lonely loser. So I get 1 for each of those pairs, and then my guy that stays behind, 4 times the square root of 2. Basically. Okay. So here, John, you had asked what happens if I only have one leg in C? That's this one right here. Here's C, A, B, C. So I have 6 squared plus x squared equals 10 squared. 36 plus x squared is equal to 100. Subtract the 36 from both sides. X squared will be 64. And I'll take the square root of that, and x equals 8. Okay. So why don't you guys try A, B, and or A, C, and D? Remembering that's x, x, x. I know it is. So we have a squared plus b squared equals c squared in a right triangle. Okay. And what we have is the right triangle, that one angle is 90, and then the other two add up to 90. But if the triangle opens further than 90, that's going to make that hypotenuse side, even though it's not a hypotenuse anymore because it's not a right triangle, it's going to make it bigger. And if it opens less than 90, it's going to make it smaller, right? Because it's bigger than 90, smaller than 90. So what happens is if a squared plus b squared does not equal c squared, but it's less than c squared, you have an obtuse triangle because that angle is opening bigger. And if it's bigger than c squared, you have an acute triangle because that angle opens smaller. So what you have is if it's equal, it's a right triangle. If it's less than, it's obtuse. If it's greater than, it's acute. And here's, oops, I went the wrong way. Just ignore that. There's pictures. So a squared, ABC. They didn't label that, but I think it's like this. ABC. Okay. Now you want, actually I labeled that one wrong. Hold on. You want C to always still be the longest side of the triangle. Okay, so the longest side of this triangle is this one. So basically you do the same thing as you were doing for the Pythagorean theorem, except instead of having an equal, you may have a less than or a greater than to make it true, and then you're just going to use that to determine, oh, this is a right triangle, oh, this is an obtuse triangle, oh, this is an acute triangle. Everybody got that so far? So we're just going to ignore that. And we'll hold on one second. Okay, so if you have a triangle and I tell you the lengths are 5, 7, and 9, okay, this is the longest side, so this one has to be C. The biggest number is always going to be C. This is A and B. It doesn't matter which is which on those, but C has to be the largest. So I'll say A squared plus B squared, and then I'll have C squared. 7 squared plus 5 squared and 9 squared, 49 plus 25 and 81, and 49 plus 25, that's 60 plus 14, so that's 74 and 81. Did I do that right? Yes. 74 is greater, not greater. Yeah, I don't know what I'm doing. 74 is less than 81. So does that make this triangle, yes, so we're going to say obtuse triangle. Okay, if it was equal, we'd say it was a right triangle. If it was greater than, it would be an acute triangle. So just to recap, equal is right, less than is obtuse, greater than is acute. Okay, so let's try these together. I have C is the largest, so I'll have 5 squared plus 5 squared and 6 squared. So 25 and 25 and 36, that's 50. 50 is larger than 36. 5 squared plus 12 squared and 13 squared, so I have 25 and 144 and 169. Those are equal. Right. Okay. Square root of 3 squared and the square root of 3 squared. The square root of 3 squared is 3. And then 9. So this is less, so it's obtuse. And then I'll have the square root of 3 squared, the square root of 4 squared, and the square root of 7 squared, so 3 and 4 and 7. So right. Not too bad? Okay, so why don't you guys, not quiz, just try these.